So I came across a story and I thought I had not heard anything about this. Whenever we talk vaccines, typically, at least for the past couple of years, it's always been about COVID and the fact that, mRNA vaccines, there are still deniers out there. And then this story talks about vaccines in a completely different way. But what's really interesting is mRNA is mentioned here as really the development that is helping, or at least helping some doctors, some scientists, treat different cancers with vaccines, something completely different that hasn't happened up until now. So we thought we'd try to find out more. Dr. Christopher Labos is a cardiologist with a degree in epidemiology. He's on, by the way, Sunday mornings with Ken Connors. That's at 8:10 a.m. Dr. Labos, look, vaccines have been around obviously for a long time. And in reading about the story, it said they've been used, but the development of mRNA vaccines specifically has kind of changed the game here. Is that accurate? Is that what they're saying?
Yeah, I think so. I mean, here's the thing. We talk about the mRNA vaccines and mRNA technology in the context of COVID because that's when, the first time most people had heard about it. But mRNA technology had existed prior to this. It's just that most of the research on it was being done in the context of cancer therapy. And, it was still very, very preliminary. But mRNA technology is not new, and people had been researching it for decades. It's just that they hadn't been able to use it for a practical purpose yet. And so when COVID came around and everybody said, let's use this technology to make the vaccines faster. And it worked quite well, despite what, many people like to say on the internet now. And so a lot of people think of mRNA technology in terms of traditional vaccines, but in fact, the future of it and where most people are talking about is in terms of the use of cancer treatments. And we talk about them as cancer vaccines because that's just how we speak. But they're not vaccines in the sense that they're going to immunize you against getting cancer. It's more, if we want to think of it that way, as an immunotherapy type thing. So we would use it to sort of treat cancer to get your immune system to start killing off cancer cells, which it largely does. Your body over the course of your lifetime is going to, develop a number of little tumors, which are basically just dysfunctional cells, and your immune system is usually able to kill them off before they start to spread. It's just that with cancer, your immune system can't quite get it under control, and that's why those initial cancer cells end up growing and becoming tumors and metastasizing. So this is really about a form of immunotherapy, which itself already exists in some ways, right? Most people who have cancer will know that a lot of the chemotherapy that we talk about now would be more accurately referred to as immunotherapy, using the immune system to kill off and treat cancer.
So I have one question before. I know Natasha has a question as well, but my question is, this is in conjunction with existing therapies. In other words, you're not getting a vaccine to completely eliminate one particular kind of cancer. We're not at that stage. You still would go through your regular channels of treatment.
Right, essentially. Now, again, if you want to get really philosophical about it, there are vaccines, traditional vaccines that prevent cancer, and I'll give you a perfect example so that we don't tend to think of it in this way, but think of the HPV vaccine.
That was exactly what I was going to ask. Yeah, go ahead.
Yeah, I mean, that's essentially a vaccine that prevents cancer. So some cancers, not all, but some cancers are actually caused by viral infections. And HPV is the obvious example. And so a vaccine against HPV is preventing, the human papillomavirus infection, which is what leads to cervical cancer in women. So that's a vaccine that's preventing that specific type of cancer. So that will be useful for certain situations. But when people talk about mRNA technology and mRNA, quote unquote, vaccines for cancer, they're really talking about delivering a specific mRNA sequence to the cell so that your body can start making a particular protein to then fight off cancer. And so they would use it as a treatment for whatever cancer you happen to have.
Could they be used in conjunction?
Yeah, I mean, there's no reason why they couldn't. It is a different thing. I mean, also, when you go for chemotherapy, depending on what cancer you have, you don't get one treatment now. You actually get multiple different types of treatments. And let's think about breast cancer, for example. You get surgery, you get your radiation therapy, you get traditional chemotherapy, you get different medications that block estrogen levels, so you get hormonal therapy. There are a lot of things that are, in fact, immunotherapy. If we think of like Herceptin, for example, which is an antibody specifically against the HER2/neu receptor. So you get multiple different treatments that attack different parts of the problem. And so there's no reason philosophically or conceivably that you couldn't use this in conjunction with anything else, depending on how successful it is. We don't really know what the ultimate potential of mRNA technology for cancer therapy is going to be. People have been talking about it for a while, but nobody has successfully used it yet.
Yeah, and of course, like so many other treatments, it depends on the kind of cancer. From what I read, Dr. Labos, this may be more effective against certain types of cancer than others.
Right, and there's also a question of, how much room do you have to improve upon? If you take something like breast cancer, just to keep using the same example, I mean, the treatments for breast cancer are already very, very good. So to show a benefit in breast cancer, you would have to be above and beyond what already exists, which is a much higher threshold than a situation like, for example, pancreatic cancer, where the treatments are not that good, where there's a lot of room for improvement. So, a lot of this is speculation. It's an easy thing to say. It's the practical realities of making this stuff work in a real clinical setting. But yeah, this is not going to be a universal solution to cancer, because cancer is not a single disease. Cancer is a grab bag term that we use for a lot of different diseases. Because if you think about lung cancer, breast cancer, pancreatic cancer, they're caused by different things. They're treated differently. They just have a common pathological mechanism, which makes us think about them similarly. But the reality is we probably should think about them differently, because they are very different diseases. And so there will never be a cure for cancer, because cancer isn't one thing.
Right, and the cancers all behave differently. I was thinking, Dr. Labos, about how the advancements that have been made, I mean, they're staggering, obviously, and yet I wonder how frustrating it is for doctors that they don't advance more quickly. Do you find that things go slowly on the whole when it comes to, again, you can't find a cure for cancer per se, but cancer treatments?
Yeah, it's obviously frustrating, because you could spend your whole career just working on one particular advancement. And, again, you have to sort of zoom out and look at stuff historically. And again, I'll just keep harping on breast cancer, because that's the example that people use. If you look historically at how breast cancer evolved over the past 50 years, there were remarkable strides in terms of the surgeries becoming less invasive and less destructive, radiotherapy going from its original formulations to fractionated radiation therapy, which was less damaging to the surrounding tissue, and the improvements in chemotherapy in terms of the development of things like tamoxifen and arimidex and all the hormonal therapies, which are remarkably effective and have no side effects. But all of these changes happen slowly. So if you were living through them, it was very frustrating, because, when we talk about things in terms of, short term, like, is this something that's on the horizon? Yeah, we usually talk about it being on the horizon in the next 5 to 10 years. So for people who want things to happen from one day to the next, it is hard, because, and again, people, I think, have a artificial view of how quickly things can work. Because during COVID, we got the vaccines over the course of a year. And that was amazing. But that was literally a situation where basically government opened the coffers and said, no cost is too high. Take what you need. And they really cut out a lot of the red tape to just have the pure science. A lot of that red tape is back, and some of it is justifiable, because you want to have those safeguards and those regulations in place. But there's a lot that we could do to make the process go faster. And frankly, a lot of the most frustrating part of doing research is not the doing of the research. It's it's the paperwork. It's the getting funding. It's applying for grants. It's applying for peer review, revising and editing your manuscripts before they get published. So things take very, very long. And it's, the comment I hear from a lot of people is like, I wish somebody would just let me do my research and leave me alone with all the paperwork stuff. But unfortunately, it's the paperwork stuff that ends up sucking up so much of your time and is the great source of frustration for a lot of people.
I just want to ask one last thing as we run out of time here. Part of the story that I read on these vaccines and treating cancer, and as you said, there's so many things or different things that are cancer. And then I read that I think it's Merck and Moderna have teamed up and are actually working on what they call a personalized vaccine, which basically would be customized to each patient depending on what they're working with, which is, when you think about it, pretty incredible.
Yeah, it is. And again, we've sort of been working towards that. So, when you get specific immunotherapies, you get specific antibodies based on if your cancer has that specific receptor. So a lot of people have, when are we going to start doing personalized cancer therapy? Like, well, we've sort of been doing it for the past 20 years, to be quite frank about you, because when they do a biopsy of your cancer, they're actually looking to see which receptors do you have and giving you the antibodies directed against those receptors. So this is not new per se. It's just that the advantage of the mRNA vaccines is they can give you a specific bit of mRNA specific to you and your cancer, in theory. And that's the great advantage of the mRNA platform, is it really allows you to sort of tailor the therapy to the specific patient, or to be more accurate, probably to a specific group of patients that have similar problems.